Hello, everybody. Welcome back to another visual pattern challenge. Here is our pattern today. Here's step 1, step 2, step 3, and your challenge is to predict the number of little plus signs in step 4. If you can do that, can you predict the number in step 43? And can you write an equation to predict the number of plus signs in any step at all? If you'd like to accept that challenge, pause the video and see what you can do. All right, so, what do we have going on here? It looks like sort of arrangements of plus signs in sort of triangular patterns that grow, and looks like there's an even number of plus signs in each row. So we've got a row of 2, 4, and 6, and then 2, 4, 6, and that's 8, aha, and then 2, 4, 6, 8, and 10 down here. So in the next step, if it followed that pattern, I would expect 2, 4, 6, 8, 10, and then a new row of 12. So whatever all that is, let's see if we can add that together. So 2 and 4 is 6, and 6 is 12, and 8 is 20, and 10 is 30, and 12 is 42. So my prediction for step 4 would be that there are 42 plus signs. Now, you may have seen a pattern like this before, especially if you've been following along with these videos every day. And when you keep increasing the amount you're increasing by 2, you might know what kind of a pattern we're going to end up with. If you're not quite sure, I think the step to take is just to analyze the numbers in a chart. So we're going to do that. So I'm going to make the step number and the number of plus signs. So in step 1, that is 12. In step 2, that's 8 more, so that's 20. In step 3, we've got, that's 30. And in step 4, we're predicting 42. So once we've got the numbers arranged in a chart, we can take the difference between each step. So 20 minus 12, that's 8. 30 minus 20 is 10. And 42 minus 30 is 12. That is not a constant, so we know this isn't a linear pattern. We can go ahead and take the difference of the differences. 10 minus 8 is 2, 12 minus 10 is 2. There we're getting a constant. So if you get a constant in the second order differences, the difference of the differences, you know it's quadratic. We still don't know what the equation is, and this one's a little complicated. And I think it's hard, just because of the way these shapes are arranged, to really see any coherent pattern of squares in there. So I think my approach with this one would be to analyze these numbers and to think about, I don't know, maybe a good way to approach this would be, what's the biggest perfect square inside of 12 and 20 and 30, and then see what's left over. So I'm actually going to make a new chart, and we're going to make the step number here, and then let's see. Well, the biggest perfect square inside 12 would be 9. So let's just try 9, and that would leave 3 over to get to 12. And then 20, the biggest square would be 16, and I'd need 4 more to get to 20. And in step 3, 25, and I'd need 5 more. And in step 4, 36 would be the biggest one, and that would leave 6 more. And look at that. So I just took a shot in the dark here with trying to look for the squares inside of the numbers, because we knew it's quadratic. And this is a very regular pattern. So this is 3 squared plus 3, 4 squared plus 4, 5 squared plus 5, 6 squared plus 6. So we know, the next step should be 5 squared, should be 7 squared plus 7. And in step 43, it's going to be 45 squared plus 45. So what we've got here in this pattern of numbers is an easily recognizable formula. This 9, this is 3 squared. That's 2 greater than the step number, and then squared. So we can write that as x plus 2 quantity squared. So that would give us, in step 1, 3 squared, in step 2, 4 squared, etc. And then we've just got this, and that's just x plus 2. So this could be our equation. It's pretty complicated looking. It does, portray what's in this chart pretty well. I think I'm going to FOIL things out and combine the like terms. So let's see. I would get x squared plus 4x plus 4, and then plus another x and plus 2. And if I combine the 4x and the x and the 4 and the 2, I would get x squared plus 5x plus 6. So this is what I think the equation is. I'm going to jot it down here, but we'll test this on a couple of numbers as well. So x squared plus 5x plus 6. Pretty complicated. Hard to have seen that easily in the pattern, which is why I chose to look at the numbers instead of the shapes here. But let's try this out. In step 1, that would be 1 squared plus 5 times 1 plus 6. And that would be 1 plus 5 plus 6. Yeah, that's 12. That works out. In step 2, it'd be 2 squared plus 5 times 2 plus 6. So that would be 4 and 10 and 6. Yeah, that's 20. And you can go on testing it with the other numbers if you like, but I think we've got our equation. So how many in step 43 requires just putting in 43 for x here. So I would say y equals 43 squared plus 5 times 43 plus 6. And let's see, 43 squared is 1849. And 5 times 43 is 215 and another 6. And I think I'm getting 2070. So 2070 plus signs in step 43. Is that what you got? You want to check my math and let me know if I got it right? How did this go for you? Did you get 42 for step 4? Were you able to arrive at an equation? I think this one's pretty tough to get to an equation. Let me know how it went. Thanks, everybody.